They share some similarities, surprisingly. So we work both, helping bring in to the telco stack to what's called the multi-edge access compute. It used to be called mobile edge compute, MEC. I think is the general word that you would use. In the consumer land, what you find is that, you have all these embedded architectures where you're trying to really do all these techniques of porting, using tools like Apache TVM, right, or OctoML, for example, pushing them, porting the architectures, pruning the architectures, quantizing the architectures all the way down to an 8-bit, looking at which layers and which operators are supported. And that's on the consumer edge to really leverage the wattage, the power, the heating, all these constraints that you have on your chip. Now, when you go to the provider edge, surprisingly, people think, well, that should be like a region in AWS, and it's not, right? This is prime real estate. You cannot end up with these huge data centers in the middle of San Francisco. So what you have is relatively high compute density, not a lot of it, but very high compute density, but very low storage. And is designed really to address mostly the low latency use case today, and towards 5G start to address the high bandwidth use case, right? That 5G should really not be about just people streaming Netflix on 4K, but also the ability to now shift. So on the provider edge, what you find is that all that optimization that you have done on the consumer edge, on the consumer device, it actually makes sense to use exactly the same techniques on the provider edge, because you want to squeeze in that prime real estate every watt of power you want to extract of it as much as you can, because it's super costly, and you want to really get the return on your money.